Hello, in this lecture we will find the area of the green circle. In the drawing we have triangle ABC, side AB of triangle ABC equals to 13 units, side AC equals to 14 units, and side BC equals to 15 units. And we also have this green circle that it is inscribed inside the triangle ABC. Side AC of triangle ABC is tangent to the green circle at this point. We will define the point of tangency as point D. Side AB, point D is the launch point between tangent AC and the green circle, and we know that side AB of triangle ABC is tangent to the circle at this point. We will define this point as point E. Again, point E is the launch point or the point of tangency between tangent AB and the green circle. And side BC of triangle ABC is tangent to the green circle at this point. We will define this point as point F. Point F is the launch point between tangent BC and the green circle. So we will define side AB of triangle ABC as A, that is to say AB equals to A, and A equals to 13 units, and side AC of triangle ABC will be defined as C, that is to say AC equals to C, and C equals to 14 units, and side BC of triangle ABC will be defined as B, that is to say BC equals to B, and BC equals to 15 units, so B also will be equal to 15 units. Okay, so we know that AB equals to A, that equals to 13 units, AC equals to C, that equals to 14 units, and PC equals to B, that equals to 15 units. Okay, and we want to find out the area of the green circle. So first of all, we will define a new term. The term that we will define is semi-perimeter of a triangle. So, what is the semi-perimeter of a triangle? The semi-perimeter of a triangle is the perimeter of the triangle, that is to say, the sum of its sides over 2. Okay, it equals to the perimeter of the triangle over 2. Okay, the semi-perimeter of any triangle equals to the perimeter of the triangle over 2. So actually, if we have triangle ABC, and we know that side AB of triangle ABC equals to A units in size, side AC equals to C units in size, and side BC of triangle ABC equals to B units in size. Then the semi-perimeter of this triangle will be equal to the perimeter of the triangle, that is the sum of its sides. That is to say, it equals to A plus B plus C, the sum of its sides over 2. So that is the semi-perimeter of this triangle ABC, and we mark the semi-perimeter by the letter S. That is abbreviation for semi-perimeter. So S, the semi-perimeter of this triangle ABC, equals to A plus B plus C over 2. Okay, so we can calculate the semi-perimeter of our triangle ABC, according to this formula. The semi-perimeter of our triangle ABC, S will be equal to the sum of the sides of our triangle ABC, that is actually A plus B plus C over 2. Okay, so the semi-perimeter of our triangle ABC will be equal to the sum of triangles ABC sides, that is A plus B plus C over 2. But we know that A equals to 13 units, B equals to 15 units, and C equals to 14 units over 2. So the semi-perimeter of our triangle ABC equals to 13 plus 15 plus 14 over 2. 13 plus 15 is 28, and 28 plus 14 is 42, and 42 over 2 is 21. Okay, so I'll write it down. 42, 28 plus 14 is 42 over 2. 42 over 2 is 21. So the semi-perimeter of our triangle ABC equals to 21 units. Again, the semi-perimeter of our triangle ABC equals to 21 units. So in the next step we will calculate the area of our triangle ABC according to a special formula. The new formula that I will present you is the area of any triangle. A is abbreviation for area. Area of any triangle equals to the root of S is the semi-perimeter, times S minus A is the size of one of the triangle's sides, times S minus B is the size of one of the triangle's sides, times S minus C. And C is also the size of one of the triangle's sides. So we will calculate the area of our triangle ABC according to this new formula. So we know that in our triangle ABC, we have already found out that the semi-perimeter of our triangle ABC equals to 21 units. So S equals to 21 units. A equals to 13 units. B equals to 15 units. And C equals to 14 units. Okay, so actually we have the values of all the variables of this formula, and the only thing that is left is to put the data that we have inside this formula in order to find the area of our triangle ABC. So the area of triangle ABC, according to this formula, will be equal to the root of S is 21, S minus A is 21 minus 13, S minus B is 21 minus 15, and S minus C is 21 minus 14. So the area of our triangle ABC equals to the root of this expression. We know that 21 minus 13 is 8, 21 minus 15 is 6, and 21 minus 14 is 7, so I'll write it down. So the area of triangle ABC equals to the root of 21 times 8 times 6 times 7. Okay, so the area of triangle ABC equals to the root of 21 times 8 times 6 times 7. The outcome of this multiplication equals to 7056. So the area of triangle ABC equals to the root of 7056. Okay, in the root of 7056 equals to 84 square units. So the area of triangle ABC according to the new formula equals to 84 square units. Okay, so after we found out the area of triangle ABC, we will find the radius in the area of the green circle. So we will define the center of the green circle as point O. Again, point O is the center of the green circle. Then we will connect together points A and O by a straight line. And we will also connect together points B and O by a straight line. And we will connect together points O and C by a straight line. So actually we created 3 small triangles inside the big triangle, triangle ABC. We have triangle AOB, triangle AOC, and triangle BOC. And the sum of the areas of the 3 small triangles equals to the area of the big triangle, triangle ABC, because of the fact that triangle ABC contains exactly the 3 small triangles. Okay, so in the next step we will draw 3 radiuses of the green circle. So the radiuses will start from the center of the circle, that is point O, and will touch the launch points of the green circle that actually the points E, D and F. Okay, so the first radius starts from the center of the green circle and touches the circle at point E. That will be R, the radius of the green circle. Actually, the radius, this radius of the green circle is drawn to the launch point, that is point E. Then we will draw the second radius of the green circle that starts from the center of the circle and touches the circle at the launch point, that is point D. The launch point is between the circle and tangent AC. Here the launch point is between the green circle and tangent AB, and then we will draw This is the radius, and then we will draw the third radius of the green circle that starts from the center of the circle and ends at point F, that is the launch point between tangent BC and the green circle. So actually this radius is drawn to the launch point, that is point F. Actually it touches the launch point, point F. Okay, so actually we have a rule, I will call it rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to the launch point. So I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So actually, according to rule number 1, whenever you draw a radius that is drawn to the launch point, then that radius will be perpendicular to its tangent. For example, this radius is drawn to the launch point, point E, therefore that radius is perpendicular to its tangent AB, that is to say this angle is a right angle and this angle is also a right angle. And the same thing is about this radius, is drawn to the launch point, point D. Actually it touches the launch point, point D, therefore this radius is perpendicular to its tangent AC, that is to say this angle is a right angle and this angle is also an angle that equals to 90 degrees. And we have this third radius that is drawn to the launch point, point F, and it is actually touches the launch point, therefore this angle is a right angle, and also this is a right angle. Okay, so actually we will create an equality that states that the area of the big triangle ABC equals to the sum of the areas of the three small triangles, triangle AOB, triangle AOC, and triangle BOC. Okay, so the area of triangle ABC, A is abbreviation for area of triangle ABC, that we already found out that it is equal to 84 square units, equals to the sum of the areas of the three small triangles, that is to say, it equals to the area of the small triangle AOB plus the area of the small triangle AOC plus the area of the small triangle BOC. Okay, again, the area of the big triangle ABC, that equals to 84 square units, equals to the sum of the areas of the three small triangles, that is to say, triangle AOB plus the area of triangle AOC plus the area of triangle BOC. Okay, because of the fact that triangle ABC contains exactly those three small triangles, so its area, it will be equal to the sum of the areas of the three small triangles. Okay, so actually, what is the area of triangle AOB? This triangle AOB, the area of triangle AOB will be equal to the base of the triangle times the height to the base over 2. So the base of this triangle AOB equals to AB times the height to the base. The height must create 90 degrees with the base, and as you can see from the drawing, the radius indeed creates 90 degrees with the base AB. Therefore, the radius of the green circle is the height of triangle AOB. So it is the base AB times the radius, the height is the radius over 2. So the area of triangle AOB equals to the base of triangle AOB, that is AB, times the height to the base, that is the radius of the green circle, over 2. Okay, in the same way, we will calculate the area of triangle AOC. What is the area of triangle AOC, this triangle? The area of triangle AOC will be equal to the base of triangle AOC, that is AC, times the height to the base. The height to the base must create 90 degrees with the base AC, so the height is the radius of the green circle, because the radius creates 90 degrees with the base, so it is times the base AC times the height, that is the radius of the green circle, over 2. So in total we got that the area of this small triangle AOC equals to the base of triangle AOC, that is AC, times the height to the base, that is actually the radius of the green circle, over 2, plus the area of the small triangle, triangle BOC. What is the area of triangle BOC? It is actually equals to the base of triangle BOC, that is actually BC, times the height to the base, and again the height must create 90 degrees with the base, and the radius indeed creates 90 degrees with the base BC, therefore the radius is the height of triangle BOC over 2. So in total we got that the area of triangle BOC equals to BC times the radius over 2, that BC is the base and the radius is the height to the base, over 2. Okay, so again this equality states that the area of the big triangle ABC equals to the sum of the areas of the three small triangle, triangle AOB, triangle AOC, plus triangle BOC. But what is the value of AB? AB equals to A and what is the value of AC? AC equals to C and what is the value of BC? BC equals to B so we got equality that states that 84 equals to AR over 2 plus CR over 2 plus BR over 2. Here we can take R, we can take out R over 2 as a common factor of this expression. Okay, so we get that 84 square units equals to the common factor that we took out of this expression is R over 2, and inside the brackets we will have here A plus C plus B. Okay, in total we got that 84 equals to R over 2 times A plus C plus B. But what is the value of A? A equals to 13 units, C equals to 14 units, and B equals to 15 units. So we got that 84 equals to 1 over 2, and in the brackets we have 13 plus 14 plus 15. So 13 plus 15 is 27, and 27 plus 15 is 42, so I write it down. In total we will get that 84 equals to R over 2 times 42. So we got that 84 equals to R over 2 times 42. 42 over 2 is 21. So 84 equals to 21 times the radius of the green circle. Okay. $84 equals to 21 times the radius of the green circle. Here we can divide this equality by 21 in order to get the radius of the green circle, the value of the radius of the green circle. So the radius of the green circle equals to 84 over 21, and 84 over 21 is 4. So we found out that the radius of the green circle equals to 4 units. Okay, the radius of the green circle equals to 4 units, and the area, after we found out that the radius of the green circle equals to 4 units, it is very easy to find out the area of the green circle, because the area, the formula for the area of any circle, A is the area of any circle, equals to pi times the radius of the circle squared. Okay, that is the formula for the area of any circle, pi times the radius of that circle squared. But we know that R equals to 4 units, so we can substitute R in this equality by 4. So we will get that the area of the green circle equals to pi times R square. R equals to 4, so it is pi times 4 square. Pi times 4 square equals to 16 pi square units. So the area of the green circle equals to 16 pi square units, or in terms of numbers, the area of this green circle will be equal to 50.265 square units. Okay, so again, the area of this green circle equals to either to 16 pi square units, or in terms of numbers, the area of this green circle equals to 50.265 square units. Okay, in the next step, I will present to you a second method, a second way to find out the area of triangle ABC. So it is a second way to find out the area of triangle ABC. Again, I will present to you a second method to find the area of triangle ABC. Actually, we will use the law of sines in order to find out the area of this triangle ABC. So, what is the law of sines? The law of cosines. We'll use the law of cosines in order to find out the area of triangle ABC. So, what is the law of cosines? I must emphasize that the law of cosines is valid in any triangle. That is to say, you can use it in any triangle. So, in any triangle, if we have triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. and we know that the size of side AB of triangle ABC equals to A units, and the size of side BC of this triangle equals to B units. And we also know that the angle between side AB and side BC is theta. And we know that the size of side AC of this triangle is C units. Then the following equality is true. That is actually C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, again, C square equals to A square plus B square minus 2 times A times B times cosinus theta. So actually we can implement the law of cosines in our triangle ABC. So I will draw triangle ABC again. So this is our original triangle ABC, and actually this angle is angle theta. Actually theta or cosinus theta is the only missing variable in this equality. So by solving this equality, we'll find out the value of cosinus theta, because cosinus theta is the only missing variable. We know the value of A is 13, the value of B is 15, and the value of C is 14 units. So we will put the data inside this equality, and in this way we will find the value of cosinus theta. Okay, so C square C equals to 14 units, so C square is 14 square, and 14 square is 196 equals to A square. A equals to 13 units, so A square is 13 square, 13 square is 169 plus B square. B equals to 15 units, so B square is 15 square, and 15 square is 225 minus 2 times A times B times cosinus theta. A equals to 13, B equals to 15. So 2 times A times B is 2 times 13 times 15. That is actually 390 cosinus theta. So in total, after we put the data inside this equality, we granted 196 equals to 225 minus 390 cosinus theta. 169 plus 225 equals to 394, so I will write it down. So in total we granted 196 equals to 394 minus 390 cosinus theta. Here we will subtract 196 from this equality and we will get that 0 equals to 394 minus 196 equals to 198 minus 390 cosinus theta. Okay, so here we will add to this equality 390 cosinus theta. Okay, so in total we granted 390 cosinus theta equals to 198. Here we will divide this equality by 390 in order to get the value of cosinus theta. So we learned that cosinus theta equals to 198 over 390, or cosinus theta equals to 0.507962 okay, cosinus theta equals to 0.507962. Actually, we want to find out the value of theta itself. In order to find out the value of theta, we will use the inverse function of cosinus, that is arc cosinus, on the outcome in order to find out the value of theta. So the inverse function of cosinus, that is arc cosinus of 0.507962 equals to 59.49 degrees. Okay, so actually found out that theta equals to 59.49 degrees. Again, we operated the inverse function of cosinus, that is arc cosinus, on the outcome, and in this way we got the value of theta itself. Theta equals to 59.49 degrees. So actually we know that theta equals to 59.49 degrees. Okay, now it is very easy to find out the area of triangle ABC, because we have all the data that we need in order to find the area of this triangle ABC. So here we will draw a perpendicular to side BC from point A. So this is a right angle and this is also a right angle. We will name the point of contact between the perpendicular to side BC, point D. And actually triangle ABD is a right triangle, so because this angle is 90 degrees, so triangle ABD is a right triangle. So in triangle ABD, in the right triangle ABD, sinus 59.49 degrees will be equal, we will name AD, will define AD as H, that is the height of triangle ABC, the height to the base B. Okay, AD equals to H. So actually sinus of 59.49 degrees equals to H over A. Okay, so in the right triangle ABD, this triangle, sinus of 59.49 degrees equals to h over a. Okay. Sinus of 59.49 degrees equals to h over a. But we know that a equals to 13 units, so I'll write it down. And sinus of 59.49 degrees equals to 0.8615. It is equals to h over a equals to 13. So we got this equality, that's 0.8615 equals to h over 13. Here we will multiply this equality by 13 in order to get the value of h, that is the height of triangle ABC when the base is B. So h equals to 13 times 0.8615, actually equals to 11.2 units. So we found out that h equals to 11.2 units. And the formula for the area of any triangle is actually equals to the base of the triangle times the height to the base. The height must create 90 degrees with the base, so the height is indeed h over 2. So the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. And especially the area, we can use this formula in order to find out the area of triangle ABC. So the area of triangle ABC will be equal to the base of the triangle, that is actually B, and B equals to 15 units, times the height to the base. The height must create 90 degrees with the base, so h is the height to the base, that is actually equals to 11.2 units over 2. So we found out that the area of triangle ABC equals to 15 times 11.2 over 2. Again, the area of triangle ABC equals to 15 times 11.2 over 2. And 15 times 11.2 is 168 over 2, and 168 over 2 equals to 84 square units. Okay, so the area of triangle ABC, according to the second method, equals to 84 square units. Again, the area of triangle ABC according to the second method equals to 84 square units. Okay, so in the next step we will find the area of triangle ABC in according to a new method that will be the third method. Okay, so I will present to you a third method to find out the area of triangle ABC. Again, I will present to you a third method to find out the area of triangle ABC. Okay, so according to this method, we will divide triangle ABC to two parts. Actually, we will divide triangle ABC to two right triangles, and in this way we will prove that if the base of the triangle is 14 units, then the height to that base will be equal to 12 units, and the area of any triangle equals to the base times the height of the base over 2, that is to say the area of our triangle ABC will be equal to the base that is 14 times the height to the base that is 12 over 2. 12 over 2 is 6, so in total we will get that the area of triangle ABC equals to 14 times 6, that is actually 84 square units. Okay, so we'll start by dividing triangle ABC to two right triangles. The first part of triangle ABC after we divide it to two parts will be the hypotenuse of this right triangle will be equal to 13 units. We have one perpendicular of 5 units and the other is 12 units. So this triangle is a right triangle because it obeys to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say 13 square equals to 12 square plus 5 square. So if this triangle obeys to the Pythagorean theorem, that is true only in right triangle, then it must be a right triangle. So we'll check if the right side of this equality equals to the left side of this equality. So 13 square is 169 equals to 12 square is 144 plus 5 square is 25. So we got that 169 equals to 144 plus 25, and 144 plus 25 is indeed 169. So this is a right triangle. In the next step, I will draw the second part of triangle ABC after we divide it to two right triangles. After we divided it to two right triangles. So the second part of triangle ABC will be the following right triangle. This side is side of 12 units. This side is the hypotenuse of the right triangle that is equal to 15 units. And this side is the side that equals to 9 units. So this is a right triangle, and we will prove that this is a right triangle by checking whether if it is obeys to the Pythagorean theorem or not. If this triangle obeys to the Pythagorean theorem, then it must be a right triangle. So we will check whether if 15 square equals to 12 square plus 9 square. So 15 square is 225 equals to 12 square is 144 plus 9 square is 81. And indeed 225 indeed equals to 144 plus 81. So this is a right triangle. Actually, if we combine together those two right triangles, we will get the original triangle, triangle ABC, because triangle ABC has three sides with 14 units, 13 units, and 15 units. So if we combine those two sides together, here 9 plus 5 is 14, so this side will be equal to 14 units. Here we have 13 units. And here we have 15 units. So actually we received this triangle after we combined those two triangles together, 14 units, 13 units and 15 units. And so this is the original triangle, triangle ABC, and this side equals to 12 units. So actually So again, this is the triangle ABC that we received after we combined those two triangles together. Again, in this way, we proved that if the base of triangle ABC is 14 units, then the height to that base is 12 units. This side creates 90 degrees with the base. Therefore, this is actually the height to the base that is 14. So the area of any triangle equals to the base of the triangle times the height to the base over 2, and the area of triangle ABC will be equal to the base of triangle ABC, that is actually 14 units, times the height to the base. The height creates 90 degrees with the base, and indeed this side creates 90 degrees with the base, so the height is indeed 12 units over 2. So the area of triangle ABC equals to the base of the triangle, that is 14 units, times the height to the base, that is 12 units over 2. Here 12 over 2 is 6, so I write it down. So we got that the area of triangle ABC equals to 12 times 6, that is 14 times 6. 14 times 6 is 84 square units, so the area of triangle ABC, according to the third method, equals to 84 square units. Okay. Again, the area of triangle ABC, according to the third method, equals to 84 square units. Okay, so in the next step, we'll present to you a second way to find out the radius of the green circle. In the first way, we found out the radius of the green circle by dividing triangle ABC to 3 small triangles, and we created the equality that states that the sum of the areas of the 3 small triangles equals to the area of the big triangle, triangle ABC. In this way, we found the radius and then the area of the circle. In the second way, I will present you another method to find out the radius of the green circle. Second method, to find the radius of the green circle. Again, I will present to you a second method to find out the radius of the green circle. Actually, we can use the following formula in any circle that is inscribed inside a triangle. So in any circle, that it is inscribed in a triangle, the following formula is true. Again, in any circle that it is inscribed in a triangle, the following formula is true. We can find out the radius of the circle that is inscribed inside the triangle according to the following formula, that the radius of that circle will be equal to the area of the triangle that contains the circle over the semi-perimeter of that triangle. Again, the radius of any circle that it is inscribed inside the triangle equals to the area of the triangle that contains the circle over the semi-perimeter of the triangle. And we have already found out that the area of the triangle ABC that contains the circle, the green circle, equals to 84 square units. Okay, the area of triangle ABC equals to 84 square units, and the semi-perimeter of triangle ABC equals to 21 units. Okay, the semi-perimeter of triangle ABC equals to 21 units. So the radius of the green circle equals to the area of the triangle that contains the circle over the semi-perimeter of the triangle. Okay, R equals to delta over S, and we know that the area of triangle ABC equals to 84 square units, and the semi-perimeter of triangle ABC equals to 21 units. So the radius of the green circle equals to 84 over 21, that is 4 units. The radius of the green circle equals to 4 units. And after we know that the radius of the green circle equals to 4 units, it is very easy to find out the area of the green circle, because the area of any circle equals to pi times the radius of that circle squared. Okay, the area of any circle equals to pi times the radius of the circle squared. We know that R equals to 4 units, so we can substitute R by 4 units in this formula, and we will get that the area of the green circle, according to the formula that we represented to you, equals to pi times r square. R is 4, so it is pi times 4 square. It's actually 16 pi square units of the area of the green circle, equals to 50.265 square units. Okay, the area of the green circle equals either to 16 pi square units or to 50.265 square units. The area of this green circle equals to either 16 pi square units or to 50.265 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green circle, and we have triangle ABC that actually contains the green circle, or the green circle is inscribed in the triangle ABC, and we know that side AB of triangle ABC is tangent to the green circle at point E. Point E is the launch point between the tangent AB and the green circle. Side AC of triangle ABC is tangent to the circle at point D. And side BC of triangle ABC is tangent to the circle at point F. And we want to find out the area of the green circle. So, actually, I presented to you a new theorem. It is semi-perimeter, or the semi-perimeter of triangle ABC with sides A, B, and C equals to the sum of its sides, the sum of the sizes of its sides, that is actually A plus B plus C over 2, or it equals to the perimeter of the triangle over 2. That is the semi-perimeter of any triangle, that we mark it as S. We mark it with the letter S. S is the abbreviation for semi-perimeter. So S, the semi-perimeter of this triangle, equals to A plus B plus C over 2. So we calculated the semi-perimeter of our triangle, according to the formula of semi-perimeter, that is actually A plus B plus C over 2. A equals to 13 units, B equals to 15 units, and C equals to 14 units. So the semi-perimeter of our triangle ABC equals to 21 units. And then we calculated the area of triangle ABC according to a special formula. We can use this formula in any triangle. The formula states that the area of any triangle equals to the root of S times S minus A times S minus B times S minus C. We know that S is the semi-perimeter of the triangle, and A, B, and C are the sizes of the sides of the triangle. We know that S in our triangle ABC equals to 21 units, A equals to 13, B equals to 15, and C equals to 14. So we have all the variables of this formula, and the only thing that is left is to put the data inside this formula. So that is exactly what we did, and we got that the area of triangle ABC equals to 84 square units. So the area of this triangle ABC equals to 84 square units. Then, in order to find out the radius of the green circle, we divided triangle ABC to 3 small triangles: triangle AOB, triangle AOC, triangle BOC, and we created the equality that states that the sum of the areas of those 3 small triangles equals to the area of the big triangle, triangle ABC. And before that, we draw 3 radiuses that starts from the center of the circle and touches the circle at the launch points between the circle and its tangent. And we have a rule number 1, that states that a tangent to the circle is perpendicular to the radius drawn to the launch point. So actually this radius is drawn to the launch point, that is point E. Therefore, according to rule number 1, this is a right angle and this is a right angle because the radius is perpendicular to its tangent AB. And the same thing about this radius that is drawn to the launch point, point E. Therefore, this radius is perpendicular to its tangent AC, that is to say this angle is a right angle and this angle is also a right angle. And also, here we have the third radius that is drawn to the launch point. Actually, it touches the launch point, point F. Therefore, according to rule number 1, this is a right angle and this is also a right angle. Okay, again, we created the formula that states that the sum of the areas of the 3 small triangles, triangle AOC, triangle AOB, and BOC, and triangle AOB equals to the area of the big triangle, triangle ABC, because the 3 triangles, the 3 small triangles are contained by triangle ABC. Okay, again, the equality states that the area of triangle ABC that equals to 84 square units equals to the sum of the areas of the 3 small triangles, and the area of triangle AOC equals to the base of the triangle, that is AC, times the height to the base, that is the radius over 2. The area of triangle AOB equals to the base of the triangle, that is AB, times the height to the base, that is the radius over 2, and the area of triangle BOC equals to the base of triangle BOC, that is BC, times the height to the base, that is the radius over 2. Okay, So we have here all the values of the variables inside this equality. We know that AB equals to A that equals to 13 units, AC equals to C AC equals to C that equals to 14 units, and BC equals to B that equals to 15 units, and the only missing variable here is the radius of the green circle. So by solving this equality, we found the radius of the green circle. We found that the radius of the green circle equals to 4 units, and then we know that the area of any circle equals to 5 times the radius of the circle squared, and we know that r equals to 4 units, so we can substitute r by 4 units, and we found out that the area of the green circle equals either to 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Okay, then I presented to you a second method to find out the area of triangle ABC. We found the area of triangle ABC by using the law of cosines. The law of cosine states that in any circle, c square equals to a square plus b square minus 2 times ab times cosinus theta. Again, c square equals to a square plus b square minus 2 times ab times cosinus theta. Actually, we know the values of all the variables inside this equality. We implemented this equality in our triangle ABC, and we know all the values of all the variables inside this equality. The only missing variable here is cosinus theta. So we put the data inside this equality, and we found out that cosinus theta equals to 198 over 490. That is actually equals to 0.507962, and then we operated the inverse function of cosinus in order to find out the value of theta. The inverse function of cosinus is arc cosinus, so we operated the inverse function of cosinus on the outcome, and we found out that theta equals to 59.49 degrees. So after we know that theta equals to 59.49 degrees, it is very easy to find out the area of triangle ABC. We actually drew a perpendicular to side BC of triangle ABC. So this is right angle, this is right angle. So in the right triangle ABD, we know that sinus of 59.49 degrees equals to h over a. Okay, sinus theta equals to h over a, and sinus of 59.49 degrees is 0.8615, and a equals to 13 units. So we multiplied 0.8615 by 13, and we found that the height of triangle ABC when the base is 15 equals to 11.2 units. The height of triangle ABC equals to 11.2 units when the base is 15 units. The height must create 90 degrees with the base, and the height h indeed creates 90 degrees with the base B. So the area of any triangle, and especially the area of triangle ABC, equals to the base of the triangle times the height to the base over 2. And we know that the base of triangle ABC is 15 units and the height to the base is 11.2 units. So the height of triangle ABC equals to 15, the base 15 times the height to the base, that is 11.2 over 2. So the height of triangle ABC equals to 84 square units. Okay, then I presented to you a third method to find out the area of triangle ABC. Actually, according to this method, we divide the triangle ABC to two right triangles. If these two right triangles, and in this way we actually proved that if the base of the triangle is 14 units, then the height to the base is 12 units, and the area of triangle ABC equals to the base of the triangle, that is 14 units, times the height to the base, that is 12 units. The height must create 90 degrees with the base, and this height indeed creates 90 degrees with the base. So the area of triangle ABC equals to the base, that is 14, times the height to the base, that is 12 units over 2. Okay, so the area of triangle ABC equals to 84 square units according to the third method. Okay, then I presented to you a second method to find out the radius of this green circle. We can use this formula in any circle that it is inscribed inside a triangle. The formula states that the radius of the circle that it is inscribed inside the triangle equals to the area of the triangle that contains the circle over the semi-perimeter of the triangle that contains the circle. And we have already found out that the area of triangle ABC that contains the circle equals to 84 square units, and the semi-perimeter of triangle ABC equals to 21 units. So the radius of the green circle equals to the area of the circle, that is 84 square units over the semi-perimeter of the triangle ABC, that is 21 units. So the radius of the green circle equals to 4 units. And after we found out that the radius of the green circle equals to 4 units, it is very easy to find out the area of the green circle. The formula for the area of any circle equals to pi times the radius of the circle squared. And we have already found out that the radius of the green circle equals to 4 units, so we can substitute r by 4 units in this formula, and we will get that the area of the circle, the area of the green circle, equals to either 16 pi square units, or in terms of numbers, the area of the green circle equals to 50.265 square units. Again, the area of this green circle equals to either 16 pi square units, or in terms of numbers, the area of this green circle equals to 50.265 square units. Okay, thank you very much.